Hello and welcome to today's learning session. My name is Prasanjit Singh and I'll take you through a lecture on version control system. So, over the course of this lecture, we'll learn version control systems, like how softwares are controlled in terms of having different versions at different times as the development progresses. So we'll discuss what are the various systems and softwares and tools used to control the versions for software applications. Then we'll move on to discuss why this is required, and then we'll discuss on some specific jargons or terminologies related to version control systems, and we'll discuss about tools and try them out hands-on. We'll discuss Git and Github and how various command line options are used in Git operations, and finally we'll have some hands-on exercises that will make you comfortable when trying version control system in your workplaces or elsewhere. So that would be it. It'll give a very good idea on using version control systems and how to go about applying them in the real world scenarios. So let's get started. First of all, let me just tell you, I would always want my classes to be graphical because I don't want people to read about definitions and just mark them up and just follow up standard things that have been delivered and normally done in the books. So the aim of this video is to have some graphical illustrations that creates a photographic memory, and so that once you learn this you never forget. So now look at this diagram. Here you can see this depicts the essentials of a version control system. Let me explain. First of all, imagine you have a project in place, a software project. We are talking about a software project, which again essentially means a bunch of code. Okay, so you have a code base which is written on different files. So you have multiple files. For example, if you're writing code for a website, so you would have a lot of HTML, CSS and PHP files, assuming the website is written in the PHP language. Or if it is a Node.js website, there would be some .js files and so on. So these code files are stored in the developer's laptop just say it could be stored in a folder, and he would have named it with the name of the project. So that's at a very initial raw stage. Now this developer owns the code, he writes the code and saves them on a folder that is named with the name of the project. In this scenario, let's enter more developers. For example, if we have 3 more developers joining the team, now 4 of them together will start working on the same code base, and then what happens? The other 3 developers, they copy the same code base and put it on their respective folders. So now we have 4 different folders with the same code until they start working. Now, for example, say developer 1 starts working on a certain module of that website, and the developer 2 works on some other module. Developer 3 is a graphic designer. He started working on the looks and the cosmetics of the websites. So he's changing the HTML, CSS files, while other 3 developers are working on the logic of the website. So they are essentially changing the PHP files. So in such a case, what happens when all the 3, because they are working for the same website and for the same project, so how do they go about merging all their folders and putting it out when that particular website goes live? So that becomes a challenge. So the solution to that is essentially a version control system, but there is a lot more to that as well. So coming back to this diagram, for example, say you have a project And in a version control system, what happens, for example, you have one file that is created, and that's the part of the project. After a few days, when multiple people are working on that particular project, more and more files are added, and at a later time even more are added. So as the number of file keeps on going increasing, and the number of different versions also keep on going increasing, so whenever a file a couple of files from multiple developers are merged, and they are pushed into the repository, then they are tagged with a particular version number, so that there is a track of things going on with respect to time. For example, in the month of February, if the version was 0.1 and the code base had just one file, in the month of March it had two files with a different version number, and so on. Now, how does this help? This helps us to create milestones, so that whenever there's a problem with the current version of the website, or if someone wishes to have an older feature back because the new feature is having issues, then we can go back to the previous milestone if the tagging is done properly. So here the version control system helps us to keep a track. It acts as a kind of a backup of a particular date. So just like we do in a time machine, we can move back and forth in time and go back to that version of code which we want. So that's how version control system works. Like with time there are changes, and those changes are tagged, and that particular code base at a particular point of time is frozen, so that if something goes wrong, you can always roll back to that particular time. Second thing, it also helps multiple developers to work on the same project, and they have tools to merge their differences and different versions that they are having on their own local systems. So version control system essentially allows you to have a versioned timeline of your code, so that you can move back and forth in time through the versions, and it also allows you to administer multiple developers working on the same project. So we'll in the as we go deeper into this theory, we'll get some more examples and we'll understand better. So let's first explore why we need version control system. That will help you to understand how to implement version control system and why you are doing it actually. So first let's understand why it's required. Then you find it more interesting because you know why it's required. Then you can know why and how to apply it. So the next slide brings us to why version control system. So basically there are four reasons for this. Number one, version control system allows you to collaborate. This one I had already spoken about in the last slide. So if we have multiple developers, say developer 1, 2 and 3 working on one particular project, then all their code bases can be merged together and put into this code repository. And then finally, if everything goes fine with the tests and other stages in the DevOps pipeline, then that code base can be committed into the server. So that way it allows for collaboration. So multiple people can write code, merge their code together, and resolve the differences. If there are certain conflicts between the code of these multiple developers, there is an option to resolve conflicts as well. So once everything is in line, then that code is pushed into a repository, and from there it's deployed to the live servers. So version control helps to collaborate. The second thing it helps is to tag. Like you can have milestones of that particular code, so you can move back and forth in time when something goes wrong with the code in the current version. So if for example we are having website which is dealing with selling products. So it's a shopping website. So in that case, for example, we have a new release of that website that we tagged as version 0.1, and there were some new features added, like adding a payment gateway or adding a new payment type. And that new feature was released as version 1.0, but there were lots of complaints on a certain feature, and it was found to be unstable. Then, since we tag every release in a version control system, so it can be easily rolled back to the previous version, instead of checking like which files had what changes and those have to be removed or erased. So that is the old way of doing it. For example, if it was without version control system, the developers would have had to figure out what was changed and have had to remove those changes. So that is very mechanical and error prone. So having a tag easily takes you back in time to that particular stage, and where the errors were not there, and then they can take it from there and fix those errors and come back to a new release or a hotfix or a patch, whatever. So we'll discuss all that in depth. So now we have two reasons why version control systems are used: collaboration, number two, tagging. Third reason is branching and merging. So what is it? In a particular working environment, there could be multiple physical environments where your code can be deployed. For example, in a team which is writing code for a website or an Android app or an iOS app, they could they do not write code and directly go live. They might be having multiple environments where they deploy the code and see whether it works fine or not, and only then it moves up the line and gets deployed in a production environment. So these different environments are fed code from different branches of the repository. For example, if I have a shopping website and I have and the project name is say shopping cart, and I have that repository created in my version control system. Now I am just in the stages of development, so I cannot put that code directly into a production branch. So I create a branch called develop, and the code from the develop branch is deployed into the development environment. If everything works fine in different iterations, I later on create another branch out of the develop branch that's called the release branch, and use that to hand it over to the testing team. So the testers test that, and if everything is found fine, then they tag it and call it a release. Like that becomes a release candidate, and then that release candidate can be another branch can be created out of that release branch, and then that release candidate can be tagged as a release and deployed to production. So that's how it works for the first time. And then onwards, developers write the code, commit to the develop branch, that triggers certain pipelines if you're following DevOps, and that builds the code and then moves on till it reaches a stage when it can be released. Then the code is merged into the release branch which we had created earlier, and then if all the test cases pass there, then the release becomes a release candidate. That's just another tag, like RC 1.0 would be the release candidate of version 1.0. And once the release candidate has been approved from all different quarters, then it is merged to the master branch, and from the master it always goes to the production. Now certain organizations also have different other branches called hotfixes or feature branches. You can just imagine these are other instances of the same code. We'll talk more about that in the forthcoming session, in the forthcoming slides, because here we are concentrating on what are the reasons we require version control for. So we know the reason already. Version control systems help us create separate branches so that there are no conflicts between environments. Like if there is an error in whatever was committed to a develop environment, that should not affect the production environments. So it helps differentiate your code which are moving on different lines. Okay. Now, apart from that, it also helps you merge your code whenever required. So, as and when required. So, for example, say you have a new feature and you feel it is mature enough to be tested. So, you can immediately merge that to the release branch so that the test cases can run there and they can be released, or there can be a staging done for that particular software. So, that's the reason we use version control system for merging as well. Like you can branch them and you can merge branches whenever required. The fourth reason is it allows you to have backups of your code. This one we had already discussed in a way of having the tags, but even even if you don't have tags, if you have multiple versions, or then it acts as a sort of a backup. Like if you lose code from a production server or from the laptops where the developers have developed their code, then even then you can bring your code base back by checking it out from the version control system. So it also acts as a backup of all repositories, so allows you to have a backup of your software assets, essentially the code base. Version control system normally doesn't take backups of databases, but there are systems where database differences are stored in form of SQL files, .sql files, and they are also stored. So these are edge cases, we'll discuss them later on. So normally code bases are the one which are under version control, and in certain organizations they also version control their config files. Like if you have an Apache server or a MySQL server and you have certain settings which are specific and customized for that particular server, then you can always version control these versions of these config files, so that if something broke, you can go back to the previous versions of that file and you can see the changes, how it moved in time, and so on. So that's all about why version control system is required. And before we move on, to do the real exercises and try out the commands and understand what are the tools that are required for version control, let's first understand one particular thing that will come again and again, that is called a repository. Like this word would pop up every next time, like it'll come up every other time when you're discussing about version control systems. So what is a repository? Repository is a collection of various code bases coming in from various sources. For example, I have 4 different developers. Each one has his code base for the same project stored in his laptop where he's working. Now say all these guys want to have it placed on a central place, so that central storage is called the repository. So when you create a project, each project has its own repository where the code is stored. So that is what the idea of a repository is. Next, we come on to discuss what are the various version control systems. So basically there are 2 different types of version control systems. There are more than the 2 which has been illustrated here. For example, one of them is called Git. There's another version control system which is called Subversion. There are others as well, like Mercurial and so on. But the Git is the most popular and the most used and the best version control system at this stage. So we'll be learning about Git essentially. these are the other version control system. We'll know about it, but mostly if you learn one of them, the others are just the same. Like it's like using different email accounts from different mail providers. You have a Gmail account, you have a Yahoo Mail account, so that doesn't make a difference. The purpose is to send mail. Similarly, the purpose here is to do the version control management of your code base. And since Git is the most popular and it is used by the most organizations worldwide, so we'll be learning Git and get comfortable with it. So but one thing you have to remember is in version control systems there are two philosophies. One is having a distributed version control system, which Git is, and another is having a centralized version control system, which is Subversion or Mercurial. So let me just tell you briefly about what this means and what are the differences, so that if someone asks you these kind of questions, like you're talking about version control system, tell me what kind of version control system Git is or how it works. So it's good to have an understanding of the underlying mechanism. So by a distributed version control system like Git, we mean the code is not centralized. For example, each person has his code on his own system, and once he checks into the Git version control system, like once he commits his code to a certain project and other people also join in the same project, then each person's laptop or desktop, wherever he's coding from, becomes a server. So you have multiple servers. You do not have a centralized server somewhere. Everyone participating in the repository becomes a server. Advantages: if someone's laptop gets destroyed or code is wiped out or deleted, then there is nothing to worry. There are 5 other or 6 other different people working on the same project, so it's just a matter of checking out the code again and coming back on sync with the others. So there is no centralized or a single point of failure there. So that's one of the biggest positives. Apart from that, there are certain tools and command lines which are very convenient to manage different administrative tasks which are used to version control your software. So we'll come to all that. So that is how Git is, a distributed version control system. Now Subversion or Mercurial, these are centralized version control systems. So you have one central server where your code base is stored, and you have certain client softwares. So using those client softwares, you check out the code from the central server, work on it, push it back to that central server, and others do the same. So whenever any change is done, the others are not aware of it unless it is pushed into that central server. So that's how it works in case of Subversion. The problem here is if the Subversion server goes down, then you are left with nothing, because you'll have your code there, but the system of versioning and everything will be wiped out. So let's come back to Git. Now we can see 3 other things here, like these are logos for different versions of Git clients. So Github is a popular Git server. These are all third parties who have adopted Git. Git is actually open source software. So GitHub, Bitbucket, GitLab, these are different organizations who have adopted the open source Git and created their own proprietary product. In this particular session, we'll discuss about GitHub, and I must mention that the commands which we use for Git essentially are the same. Like, it doesn't matter whether you're working with Bitbucket or GitLab. These are just flavors of different Git applications. So we'll be doing GitHub because it is the most popular at this point among the three. Bitbucket is also doing well, and GitLab has some fantastic features as well apart from doing version control management. We'll come to that in later sessions. So let's move to the next slide where we understand what Git is and what GitHub is. As I said, Git is the open source version, and Git, by Git you mean the software. Okay, so when we interact with some repository like GitHub, a third-party repository, then we would require a client to interact with that repository. So you should run some command from the client, whether it be a graphical client or a command line client, doesn't matter, but you use these clients to interact with the GitHub repository. So this Git, as we talk about, is the software that we install, and it acts as the client as well as the server, because this is it is a decentralized model. So it acts as a server as well as a client, but mostly the commands that we use to connect to GitHub, we call them Git client commands. Okay, so here, looking at the diagram, here we can see we have our own desktops. Like, this means the developers desktops. So they have Git client installed in them, and using that there is to and fro interactions with GitHub, which is the centralized server here. So here we are by the model of Git, using a decentralized approach, like a distributed approach, but we keep GitHub as the remote repository so that it acts as a point of merging between all these participants. Like, these guys have their local repositories on their laptop, but when they sync it to GitHub, the remote repository, so that all of them at some point merge their code and have the same code. So they push and pull from the remote repository once a while and keep in sync. So how does that work? That is depicted on the picture on your right hand side. So here we are discussing how a distributed version control system works. So as I said, there are multiple repositories. So one of them could be on the GitHub server, and these three are on three different developers' laptops or desktops. Now, when the developer writes code and he saves the code and he wants to commit it to a repository, then he runs certain commands, and that code is staged on his local repository. That doesn't mean all the others get it at that point. It is just staged and committed. Okay, just like when we write something and store it on a file, we call it saving. Like, you do a control S and you call it the file has been saved. Similarly, when you want to store something on a repository, you call that you have committed it. So once you have committed something to your local repository, that is ready to be moved into other repositories in the same ecosystem. So once you have committed something to the repository, then if you want others to be in sync with the same version, then you have to push that code. So that becomes the next step. So once the code is pushed to the other repositories, all of them start pulling the code so that they can be in sync with whatever you have committed here. So these pull and push operations go on between different repositories to ensure they are in sync. It might seem a bit vague to you at this point, but as we move on with the sessions and start doing our hands-on practice and run the different commands, then things will open up and become very clear for you. Now we go back to discuss a bit on the branches concept that we discussed earlier. As I said, we have different environments for a particular project, because you just cannot have one environment called production, because that is reserved for the production clients, like your customers, like anyone who is doing real business. He would be reading the code, using the code from your master branch. The master branch is deployed to the production environment. So no development takes place here. So a person cannot directly change. I mean, he can, but it is not allowed or not a good practice to directly change or tweak things on the master branch. So this branch is reserved for deployments in the production environment. Similarly, another important branch is the release branch. This is reserved for deployment in the staging and the test environment. Now, there would be another environment in every organization where the QA, quality assurance engineers, and or the testers would test and see whether all the functionalities are working as per requirements or not. So that branch is called the release branch. Now, when the release branch uh, is deployed, it is deployed normally to a test or a staging environment. Similarly, there is another branch where the developers commit and work on their code and develop it. That is called the develop branch, and the environment that it is deployed to is the development environment. Apart from that, there are two other branches which are used in special cases. That's the hotfix branch, somewhere they call it patch, and another branch is called the feature branch. So let me tell you about the scenarios where these branches are used. This is just for your understanding, so that whenever you come across these scenarios in the future, you would know what exactly that stands for. So let me tell you about a situation. For example, something was released and it was found to be working fine, so that release was moved on to the production branch, tagged and made live. So after the software went live, say for example, it was a software where it was a gaming software where a game is supposed to be rewarding the player with 10 points once a certain objective is met. But in this release, it was found that there was some mistake in the calculations, and the points that were awarded were having issues. Like instead of 10 points, say the calculation went wrong and 5 points were awarded for a particular function. So there were lots of complaints from the gamers, like there's a error in your logic and the number of points awarded are not as per what the gaming rules are. So we immediately require a fix because this has become a blooper, like that release has flopped. So in these cases, sometimes there has to be some quick action taken to fix the problems. Instead of waiting for the development to happen, go into release branch, test it again, fix it. Because it would be just a small calculation or a small change which the developers had missed out, and somehow the testers and other stages of evaluation have missed out and it has gone live. So in such situations, normally instead of waiting for the entire life cycle, small fixes are made, or sometimes if there are security breaches and quick fixes are needed, then we call that a hot fix. But to do a hot fix, which branch do I change the code in? Now if I change the code in the develop branch, it cannot directly be deployed here, so I'll have to again release it, and then the test cases would run, because all these are automated, assuming these are automated and you have pipelines to run, but still it will take time to do and go through all these stages. So it would be a safer option to just create another branch out of the master, do the changes there and fix it. If needed, test it on any other environment and then create a release and directly push it back, or just create a hotfix, directly push it to the master branch if it is small enough. So that's why hotfix branches are needed. Like if you want to make a quick change, you do not directly change it here in the master branch. You create a offshoot, I mean a fork out of your master branch, and then do the fixes there and then merge it back. So that's why hotfix branches are needed. Similarly, if for example outside your normal requirements there arises certain requirements that have come into the project, like something comes in which is beyond the scope of what the current planning was for the project, then these kind of things are called features. Like some new feature has come in and there is some urgent development to be done, and it cannot go in the normal way, like developing in the develop branch and doing it, because of the fear that maybe it would break the current workflow. So for these kind of situations, we create different branches called feature branches. So feature branches help to create another branch out of the master branch and allow the features to be developed independently. Now we move on to Git operations. In this particular phase of the training session, we'll discuss on what Git operations are and how they are implemented. Like this is about the commands that are going to be used, and how we would create repositories using these commands, sync repositories, make changes, and do parallel development. So we'll do them one by one, and then you'll understand better how to go about doing this. So because everything starts with the code. So once the code is ready, then the DevOps people come into action to build the code, deploy the code, and take it to the production environment. So the beginning is always from the version control systems. So next, what we do is we go to github.com, because we are using Git as the central Git server, and we are using our own server as the decentralized or the local repository. So when you do not have account, you have these options. So those who do not have the account can sign up. And now since we have the account already, so I'm just signing in. And once you sign in, if it is a new account, you would not see any repositories here, and you would see a plus sign on the top right. So you just click and create a new repository. So there is another option called import repository as well, but there are multiple scenarios. In fact, for example, say you already have some code and you just want to import it. So the easier way is to import the repository. Like if you do this, it will take you to a screen and ask you, do you already have code in some other version control system, or there is a link to your repository? This means those codes which were already present in some other Git server or SVN server or any other repository. So this also shows that Git is compatible with other version control systems. So someone has SVN and is trying to phase out that version control system called subversion, so he can just write the URL of his old repo and create and name the new repo and begin import. So all the code will come into the new repo. This is a rare case. This happens only when companies are migrating their code from some other or migrating older repositories to this new platform. So that is when it is needed. What is our plan? Our plan is just assume that a new project has come in, because we will start everything from scratch. We don't have any old things, old rep or anything. So you just imagine you are a new engineer coming in into a team and a new project has started. So they will ask you, okay, create the repo and let's get started with the pipelines so that DevOps process will begin, every automation will begin. So when you start doing that, the first step would be to create a project repository. Okay, so we for example, we know the name of the project, and by that name we can create the repository. So let's try that. So when we do it on Git, just is simple, create a new repository. Then it gives you the option like what should be the repo name. For example, let's always stick to the same example. We are doing a shopping cart, for example. That is the repository name, our project name. And here in the owners section, when you have a single account, you would just see your name. But if you create a organizational account, like for companies, there is an option to create organizational account. So it gives you those company names here with which you are associated. So when companies create an account, they specify that they are not persons, they are companies. So they get that in the drop down, but you don't have to worry about that. Like that doesn't matter. It just matters in the sense that when you choose that, you get this name in the URL of your repository. For example, every repository will have a URL like github.com, and then the name of the organization, then the name of the repository. For example, this repository contains different notes and study materials for DevOps. So uh, you will see the organization name in the beginning. Now, if you have some personal repos, you will see uh, your name alongside the repo. For example, I have some personal repos also. Like for example, this one or this Jenkins. So here you can see the name is coming in. That means this is not belonging to any organization. This is something I was doing myself. Okay. So you can choose wherever, like when you are beginning, you will just see your name because you are using your own private account. So that doesn't matter. It's just only the name which comes in the URL. So it can be a company name or a person's name if you are a standalone contributor. So I have chosen the company name because I want to do this course under this organizational name. So that's why. All right, let's go about doing it again. New repository, choose the organization. We name it shopping cart. So this should be a unique name in your repository. There can be the same repo names in other organizations, but for you, it should be the unique name because there cannot be two same repositories existing in the same organization because two people cannot work. Two different projects with the same name cannot exist. So it should be unique. And then you can put a description here. Web application, anything like whatever is explaining this project. So I'm just writing down a comment, and then this option is important. Like if you choose private, then only those who are allowed to view this project can see it. So only, for example, you can allow a few email IDs and all. So public repo, anyone can see. So anyone can be able to commit to this project, and it's available for everyone to download also. So normally companies would not do a public repo unless they are creating some open source project, like where they want contributors from outside. If it is a project specific to the company, then this would be just a public repository. So we are choosing public here. And then this step is an important step, you can say. So if I select this, if I check this, then it will create a README file where you can write the description of the project. Like we wrote this one, and you can write some more, like how to run this project, what commands are used to run these projects, and so on. So if you do this, it creates a blank project along with a file inside it. So it's better to it's a good practice to have a README file for every project. So that allows you to give an idea of what is there in the project so that people can read the description and understand what the project stands for, why it was built, and how to operate that project. So all these things filled in, and then we create a repository. So now you can see this repo is created. This is called a repo. Here is the tab called code. So we will be able to see the code. Now there is only one file inside this repo called the README. And inside that file, it's just the comments which we had given in. So first you can just know there is a code tab where you can see your code. And here there is a branch tab. and when you create a repo, it creates the master branch. So there is only one branch at that time by default, which is the master branch. Okay, and once you keep on when you add branches, more branches will appear in this drop down. So we'll come to that later again. So our first task is over, like creating a blank repo in GitHub. Now, for example, you have the project is created now. You have your shopping cart project, and there is a URL also for this particular project. Okay, if you click this is the URL of your GitHub. You can copy your actual URL from here as well. If you want to clone this project to your own system, you can copy it from here. Or if you don't want to clone, you can just download a zip file by clicking here. So I'll tell you what a clone is and what happens when you just download as a zip. So after we push code into the repo, we'll talk about the zip download and the difference between the clone. For now, you just understand, if I do a clone, this whatever content is there in the repository now, that will come back to my laptop. So for example, imagine that I am a developer and I already have this code ready. Some preliminary code is ready in my laptop. I want to put it into the repo. So for that, I first created a repo, the repository, shopping cart repository. Now I will push code into this shopping cart repository. So first one developer will do it. So imagine I am that developer who has some preliminary code ready in the laptop. He will push it into this. So what does he do and how does he do it? So if you are doing from a Linux system, then you will do it like I am doing. If you are doing from a Windows system, you will only have to do one there would be one additional step. Like I am opening a terminal in a Linux system, you will just have to do a right click, and there would, if Git is installed there, you will see an option called Git bash, and open it. It will open a prompt just like a PowerShell or a command prompt, and there you can write the same commands. Okay, this raw code, this is the folder which has the code. So let me go to the raw code folder and see what is inside. ls command allows you to list the files. Okay, ls -l. So here I can see some code of a website. So it's already there. Now I want this code to go to this repository, this new project that was created. Okay, so how will I do that? That's the thing we have to. Windows also, it would be just lying somewhere. For example, if this folder is the raw code folder in your system. Okay, and whatever is inside, you want those stuff to move here. Okay, and we have to create a repository in our local in order to do that. So first step is to clone your remote repository into a local system. So how do we do that? For that, you click here, copy your path of your repository. The path, as I said, it will be GitHub, then your organization name, then the project name .git. So I copy this one. Now I go and create a new in any other location. I'll not do that inside the raw code folder, because that is the code which I will push it later on. So what I do is I clone the existing repository into any other location. So I do git clone. This is the first command. So git clone and your path. So now what it is doing, it connected to github.com, this Binpipe and shoppingcart.git project, and downloaded stuff from there. So now we will be able to see this folder in our whichever working directory I'm working in. So you see, in the end, it has been downloaded, and this is the raw code thing. So let's get into the folder and see what is inside this shopping cart. Again, I do this. I see only one file is there. Okay, so these are the commands in the background you keep learning. Like if you're not very acquainted with Linux, just do cd, I'm changing the directory, and then ls, I'm listing the directory, so I can see only one file. I want to go one step behind, like I want to go outside shopping cart, then I can do cd dot dot, and I go back again. If I go back again into the shopping cart directory, I do a cd shopping cart and I come back again into this directory, and so on. By directory, I mean folder. In Linux, we call them directories. Okay, so now what happens? Whatever is there in this repo, readme, the same thing is there in my local. So my local repo and this repo are in sync. Now I am the developer. I have some new code which I have kept in raw code folder. So I will bring that and I'll try to do what? I'll try to commit it. Okay. So to bring the contents inside, I can do it by command line. I can also copy it directly. If you're on Windows, you can just go to your raw code folder, copy your stuff, whatever was there inside that folder. These things were there. So you can directly just do a right click, copy, and paste it into your shopping cart. Okay, but since I am demonstrating by command line, I'll copy it with the copy command. Okay, so copy -a is for copying everything, all. So I currently I'm inside shopping cart folder, so I want to copy it from one step behind. There is a raw code, and star means whatever, asterisk stands for wildcard character, which means everything inside this folder, and dot stands for the current folder. So whatever I'm doing, copying, will go to the current folder. So this is how the copy command works. Like you copy with a switch called -a, which means all copy, and then this and this. Okay, simple. But if you find this uncomfortable, no one stops you from copying it directly, because this happens in the developer system. So this part, developer will copy it and keep it in a folder. So this is a very simple operation. So the developer can directly go inside raw code, select all, copy, Control C, go inside shopping cart folder, Control V. So everything is pasted inside shopping cart. So now let me clear the screen. Now let's see what is inside shopping cart. Now you have all the code inside shopping cart. So now what do we do? If the code is here now, we can, next step is to push the code here. Okay, so how do we achieve that thing? So that is our next challenge. So in the meanwhile, I'm also showing you, like in the notes, you already apart from explaining what Git is, I have already written down the commands which we are doing right now. For example, checkout repository. So what was the command? Git clone, username, password, if it is a private repository, so that I have written it for your, safety, so that later on, because this was a public, we did not require any username. But if it is a private, you have to give your Git username and the host, like username at github.com/binpipe/ that shopping cart. So similarly, whatever is the path, you can do it. So you can follow this notes also. I'll share you these links after every session, and the previous session notes link is also there. So you can read about what DevOps is and the definitions. We discussed various phases, tools, and so on. So as we move on with the sessions, I'll keep on adding some more and more of this. Okay, so we did the first thing, checking out a code from GitHub. Now we added some of our code files into that folder. Now how do we put it into the repo. So the first step of putting it into the repo is this. Either you can do it like this, git add and the file names. Okay. So if I do it like this, then I can do git add index.html. If I press enter, it will add this index.html file to the repository. Okay. In the local repository, it will not push it to the this one, because in Git it happens in two steps. Like first you add the file, then you commit the file, and then you push the file. So there are three steps basically. So first is add, so it adds it to the local repository. Commit, you commit it with a comment like why you are doing that, and then when you push it, it actually goes to the GitHub or the central repository. So that is the first step is git add and the file name. So it will add that particular file to your git local repo. But now, since we have multiple files and folders, I don't want to add them one by one, because for example, if you have 50 files or 100 files or 1000 files, then is it practical to git add index, git add readme and so on? It is not. So in that case, you can do it. As I said, in Linux, we have a star, which is the wildcard character. That means everything inside this folder, I mean, whatever is there, should be added. So you can use that also. There is also another switch, git add -a. That way also it can be added. But I normally use this git add asterisk. So it has added these files and folders, whatever was there, into the Git repo. In Linux, normally if you see any output of a command, then fine. If you do not see any output, then also it is fine. If you see errors, then it is not fine. So like I did this and it didn't save me anything, means that it is correct. Okay. So in Windows, we always expect something yes or no or whatever. But in Linux, normally if it remains silent, like you do some action and press enter, then also it is taken as a written code is 0. That means everything is fine. If there is an error, obviously it will show the error, and doesn't show anything, that means it's good. Okay, so our add operation was done well. So next, I said whenever we use git, we do a commit. Like you add files, then you commit the files with a comment. So going to your this one, why I'm always checking through this, because so that we verify that whatever is there in the tutorial is good, and so that whenever you do it next time, you can easily refer this article so that you don't have a problem. So we can do it this way or this way. This is the first step. Then we do a commit, that is git commit and with a comment. As I said, when we do a commit means I'm sure that I'll add these files to the remote repository, and the reason is given inside a comment. So we will write initial code added. So because this is a new project, initial code is added. Say for example, someone will fix some functionality, so he will write fixed the payment gateway, or fixed this error, fixed a security problem. Whatever has been done in that change, that comment will be added. This is very important to add a comment. There are some developers or DevOps people who do not, I mean, who are too lazy to comment. They will just put a dot dot or something and just push it, but that doesn't help, because if something wrong happens in the server, then you would be blamed, like what change did you do? So it's better to always be honest here and write a comment whatever was done. So even if it breaks, it can be rolled back. We all know that Git has this time machine capabilities. It can go back in time. So whatever change we are doing now, if something breaks, we can discard them also. So I do a commit. So you can see the output had so many things here. So what was that? initial code has been added. So there were these many insertions, like it added so many files, it deleted certain files, it added some images and so on. So lots of things were added. So whatever code was there, everything was added to in this initial commit. So I'm clearing the screen. Next is but if you check this repository now, shopping cart, and refresh it, the code is still not there. So that means the step commit doesn't actually send it to the repo, okay, into the remote repo. Add just adds or lists the files to be committed. Commit does it keeps a record like which file is going to be added and what are the file system hierarchy and so on. So all those things are added here. And then the next step where you want to send it to the remote repository is you have to push it. So the command again is here. Commit part is done. Next part is pushing the change. So pushing the change, your changes are now in the head of your local working copy. Local working copy is this particular folder. So it's there. To send those to a remote repository, execute this command, git push origin master. So why we are doing this? By this we mean we are pushing it to the master branch, and we want to put the file there. Okay, so let's do that. Git push origin master and enter. If there will be some error, you will see those errors. If there will be no error, that means it's fine. Okay, so it's trying to send those objects to github.com and then it'll write those files there. Let me tell you one thing here. While executing this command, you might be prompted for a username and a password of the repository. Because I have been using this in this laptop, maybe the session is there, so I wasn't asked any credentials. But when you're doing it for the first time from your system, they'll ask you what is the GitHub username and password. So if that happens, you will just add your username and password, whatever you did when you created the GitHub account. So keep that in mind. Like it'll just ask you something like this in the prompt, user, and wait for your reply. So you will add your user there, and then when you press enter, it will ask you another prompt password. So password would not be displayed on the screen. Whatever you type will be, it will not show up there. This is pushed to the repo. So what does it say? From your local master, it goes to the remote master. So this master goes to master means it has been sent already. If there is some error, it will show up that cannot send or whatever. Okay, and this shows like what was the delta and what was moved, means what was the difference between the two repos. For now there was, everything was new, so everything was 0. For next time, if I add a file, it will show different figures here. So anyway, now let's verify whether the code came into the shopping cart or not. Let's refresh. And here we see our code present. So this is a simple website. Whatever code was there, so everything is present here. So we'll need this particular project at a later stage when we use Jenkins. So it's good that we created this. Now let's move on to the next command that we'll discuss. So so to summarize, we git cloned. So we've created a repo here using GUI, and then once the project is created, create a blank readme, and then you go to clone, copy it, then issue this command, git clone, and the path which you have copied, press enter, everything will come into your local laptop. In that particular folder, add whatever file or code you have from the developer, or if you are the developer yourself, add your code on that folder, and then run the command git add star. So that adds everything that is in folder. So if you do this, you would never need to actually write a single file name. But in certain cases, people just want to add one file instead of all the files in that folder. So there they have to specify the name of the file. So but normally this helps, like you add everything because you want that repo to be in sync with the remote repo. So git add star, that adds it. Once it is added, you write a commit message, git commit -m, and then whatever comments, like first commit or whatever, do that. So that will commit your code, and then you push with this command git push origin master. So it pushes to the master branch. Now here, let me tell you some other variations of this command. Like don't blindly just copy this command all the time. Till here, it's fine. So I didn't interrupt. For example, if the branch is not master, if you have dev branch or something else, then you have to name it. Okay. Otherwise, if you're not sure what you're doing, just write git push. That also works. Okay. It can be any version, any code, any extension, whatever. It can go to git, no problem. And all right, so let's develop on this case. Now we have one developer who has code in sync with his remote repo. He also has that code on his laptop. Now this guy works on that code. How does he work on that code? He can go to his code. For example, he wants to change this, so he will open it with Atom or whatever editor that guy is using, the developer is using. So here he will work on his code. He will make changes, do whatever he wants. So for example, I'm just demonstrating. I'm not making any changes here. So he makes the changes. Okay. And now he does a control S, saves. So there is some change in this particular code. Or for example, he adds a comment or something, or makes some changes in the code. So once this is done and he saves the page, and he closes his like for example, he fixed something or whatever, he closes his editor. Now do you think this particular thing is in sync with the repo? No, because here some new changes have been done which are not there in this index.html. Okay, why? Because we have not pushed anything. You remember slideshow comment I had written, but here it is still slideshow. So that means that change is not there. Okay. So how do we then again push the change? So as I said, that developer will work the whole day, or in between he will try to sync it with the repo. So how does this guy do it? He will first try to do the same steps. Like if it is a new file that he has added, then he will do the git add command. But have we added any new file? No, we have just changed this file. Okay, so this developer will not do the git add command anymore. Even if it does, no harm. If you forget something, like if you don't know what to do, just remember the steps. Git made a change, git add star. It will show, like if there is something to add, it will add, or otherwise it will not do anything. So you can run it anyways. If you don't run it, no problem. Okay, then next step I told, like when you make any change, a git commit is compulsory. So again you do a git commit, then you write added comments or whatever you did on that code, you write that and you commit it. So see, it automatically detected that one file has changed. There were two insertions. Remember, first I added a comment in the top, and then in the second I added some text. So it has detected all that. So that this is the beauty of the git. Like it always keeps a watch on what has changed and where it has changed, which line number, everything is recorded. Okay, and then I have committed this. Now I will push it. git push. You can write origin master. If you don't write also it will work. So let's see what happens if I don't write. It will automatically push it to the master branch because there is only one branch, so we don't have to worry. So you write these three commands, it goes to the master. Here you refresh the page, go to index, and here you can see the changes done. Here I added this text, it's there. So that way this guy keeps on working and sending it to the repository. So that is how it works. Now let's do another case. For example, we have these many files. A new file was added. Say there is a shell script was added. So this guy writes, say this is a file I am adding, test script or whatever, blah blah blah. So I'm adding all this. So I have a new file here. Okay, I forgot. This can be added in a graphical also. Like let's add one. For example, I'm just making a duplicate copy of this file. So this is a new file we have added also. So we have added two files, this one and this one. And for example, he can write this code again in the atom if he wants and make some changes. So the developer, it's up to the developer to do whatever he wants. Okay, and save that file. So once the files are saved, do the same steps again. As I said, git add. This time add is required because we added a file. So it might have added because, and then git commit -m. These are all the syntax, like you have to remember them. And once you do it a couple of times, it goes into your mind, like you will never forget. Just the three simple commands. So git add, git commit, added some code files, committed. So it shows two files were changed and one file was created, one file was added, and so on. So we did this. Next step, git push. Simple. Goes to the repo. Here you can do this. See, new file has come here, test script and so on. So that way this file creation, or that way day by day the file keeps on increasing. These people start working on the code and pushing it to the repo. The code base starts growing and so on. Then from there, how deployment is done and all that will go to the next step. I mean, that will be the next phase of using Jenkins to retrieve from here and so on. But there are still many things left here. So let's move on to the next stage. So we have a repo. One developer is having some code. He has connected his code to the repo and he can write and commit code by using those three commands: git add, git push, and git commit. And then finally he pushes it. Okay, so these three. There is also, I mean, since these things are done again and again, you can even write a script to automate this. So that is also possible. I have added a snippet in the end. That is not a part of this course, but I just added, like, if you add this snippet in a shell script, it will do these steps automatically for you. These are the three commands that you do to sync with the repo. Now imagine two more developers have come into the picture. Like two people joined the team to help this particular developer. Now those two people also have their own laptops. So how will they get this code? So again, it's the same story. Like for example, now you imagine you are also a member of this team. So what you will do, you have a Windows system. So you will go first to check this repo shopping cart. Okay. So here you will see that the repo is already there because I was the first developer and I created this. so you don't have to do the first step of creating the repo, because I told you there is a link, go to there and you will see a repository. Okay, so for you it is easy, you already see a repo, so you start from copying this path. So you started from the first command, this one, git clone, and you already have the path. So in Windows, as I said, if you have installed Git, just do a right click on any blank folder or anywhere, any location on a E drive or D drive. Just do a right click, you will see Git bash. Okay. So when you click on that, a black screen like a terminal will open up. And from there, the rest of the commands are the same. So it's pretty easy. So once the git bash opens, then first thing you do is git clone this, enter. I'm not pressing enter because I already have this, so it will show already exists. So when you do this, again the same thing will happen. It will clone this from the repo, and this guy gets the entire project on his laptop. And when he makes any changes, he will do the same thing again, like he will do a git add, git commit, and then git push. Okay, now say for example that other guy has done a git push, then how will you sync your code again with that guy? Because now you cannot do a git clone, because git clone is only done once. Okay, so because git clone will be done only in the beginning, when someone does not have that project in his laptop, he will clone it and then start working on it. But for example, if you already have it, now the second person has joined and he keeps making changes, and he informs you like, I have committed something, you can you can use it. So since he has committed, and you can see his latest commit here also. Yeah, this is one more important thing, you can see your commit and your comments here. Okay, so if you go here, you can even see what was the code, what was added, and if there was something new that was added. Okay, this entire file was added, so it shows up as green. If any line was deleted, it will show up as red, and so on. Okay, so you see all that. We can even try that if you want a deletion. So for example, I go to this shell script file and I delete these 3 lines and save the file, and I'll do the same routine, git add. You can even write it as a one-liner with semicolon. I'm just doing it differently every time so that you see that there are many techniques to do the same thing, so it doesn't matter. So you don't have to press enter again and again. So git add, then git commit, and then the comment deleted lines or whatever was done, and then the third is git push. So if I write 3 things together with semicolons, it will do all the 3 things together. Okay, so it's done. Now if I refresh this, I'll see a new commit ID. See, 11 seconds ago, this is the new commit. If I go there to see what was changed, it shows in a red. That means something was there that has been removed. What was it? This. So this way, I mean, no one can steal or cheat when using a version control system. For example, just imagine a normal scenario. Many developers are there. Someone made some mistake or deleted something, and you are asking like, who did this? That guy will say, I don't know, and no one admits to the mistake because no one likes any criticism. So in that case, you have no clue who had done it if it is someone from inside the team and has access. So you don't see any, I mean, you cannot watch over every person in the company. So you don't, or you do not record their screens so that you see what they do. So it is impossible. But when using a version control system, if any change is done and he commits something else later on also, it keeps a history of all the changes and all the commits. So that way everything is recorded. Okay, I can even see the commit that was done in the starting. Like if you click here, you can see all the commits with the person's name who did it, what time, and everything. And if you want to see what was the change done, you can go to that particular file and that particular commit and see. So it was the first time this file was added. There was no deletion, only green. So that is the power of the version control systems. So multiple people can work together and do it. So coming back to the other question, like the second guy has started working on the project, he makes a change. How do you update your repository with that change? So he makes a change and pushes it to the central repository. So your laptop is now behind. Okay, your laptop does not have that code that is there pushed by the other guy. Okay, so it's just a simple command. Go into your repository wherever your repo is. Always the commands will run from inside that path. Okay, so remember to go to that path. So for us it is inside shopping cart folder, and you do a git pull. Simple. When you are adding something, committing something, then you do a git push to send it here. When you are not adding something and you have another or many other developers in the team, there is, you can do git pull any number of times you want in a day. Git pull just ensures that whatever was there is pulled into your system. Okay, so this also brings us to another thing which you need to remember, that is, if you are planning to make any change and push it on the repo, always pull it, whatever is there, then make your change and push it. Why? For example, I make a change in the files without pulling. There is some other guy who made a change to the same file. I do not have those changes in my laptop. Now I make some changes and push it, then there is a chance that there will be conflict. Okay, so it is a good practice to always do a git pull before adding or committing or anything. Okay, so if you later on automate that process and there are multiple developers, then here you will want to add a git pull in the beginning. So git pull, git add, git commit, git push. That is a very good sequence to keep yourself safe from conflicts. Okay, but if you're only the one developer on a project, no one else will be there, you can, I mean, git pull is not required because there's no one else committing. So if I do git pull, it says already up to date. So that's fine. So there's no harm. You can run it any number of times you want. It will always check and say it's up to date. If it is not up to date, then it will tell you that some change has been done and you do not have that change in your laptop. We can mimic that also. We do not have a second developer. Like we can do that when you set up, I mean, everything is ready on your laptop, then we can try it, both of us, on the same project. But for now, I can demonstrate it in another way. Like for example, imagine this GitHub is a server. I said Git is a distributed system. So every place where there is code, that is a server. So my laptop is a server. This is also a server, you can say. So for example, someone goes and changes it on the main repo. That is also possible. So for example, I went here and I made a change. I wrote this English language, I made it FR French or something, whatever. So then I commit it here. So here I'm doing the same things from the graphical user interface of GitHub. So I'm not writing the command, I just made the change and I will save and commit it together. So there's no save button here, so we don't need to save it actually. When we commit it, it automatically saves the file. So here I'll write the comment which we do in git commit -m. That comment is here in this box. So I'll write changed language of whatever, from en to French, and commit to the master branch because we don't have any other branch. So this commit was done. If we go back to the root of the repo means the main place where you began adding the code. So you can see there is a new commit now. So it has just happened few moments ago. Now, if I do a git pull, I should see some change. I should not see already up to date because my server or git is back. I mean, it's not in sync with the master. There is something there in the remote repo which is not there in my repo. So let's do a git pull. See, it has checked that there is some change in this particular file, and there was something which was deleted and something which was added. So what was deleted? That en was deleted and fr was added. So even that would be visible in this commit, that this red is removed and the green is added. So that way people can know the entire history of things going on in a repository. So whatever has happened, the entire story is there. Green added, red removed. So if someone says I did not change and you see his name here, you can report that your commit is there, time is this, and this change was done. So you cannot get away with that. So that's how DevOps keeps a continuous track of things. So those days are gone when people will change it and play around with you. So you can be very confident on what you are doing. Only things you have to do, remember those 3 commands and add git pull to it. So 4 commands till now. The git pull, git add, git commit, git push. So that completes the cycle. So your everything is in sync with the remote. So the second guy will first do a clone and do the same things whenever he makes a change. So that is how many people, like third guy will do the same thing, fourth, and n number of people can work together in that way. So now this brings us to the thing, like we have one branch and we are working here. Okay. Now what happens when you have multiple environments? This is a production and we have a master branch, but in normal companies, you do not have one branch because no one is directly working on production environment. So there should be a development branch, there should be a staging branch, a test branch, where different teams might be doing their own operations. So dev team will be working on a dev branch. If everything goes fine, they merge it into a test branch. Then the test team tests on a test branch, and then they merge it into a staging branch normally. Staging, what happens? The client is shown the staging branch, like whenever we call the client and whatever he wanted that has been delivered, we can demonstrate it on the staging. So we stage it there, so he sees it and approves it. If it is not the client, it could be a higher level management person who will approve, okay, this is good, you can make it live. And if provided the quality tests and all other things have passed, then it is merged to the master. So master comes in the end. We were doing it here just for the sake of understanding, like, because initially when we create a repo, by default master branch is created. So we were trying it out here. Now, for example, you have a company where you have code ready in the master branch. Now you have to create your code for development purpose. So we will need, say, 2 other branches, a test branch and a develop branch. Okay. So how do we do that? So creating branches is very easy. You can do it from this GUI or as well as command line. No one stops you from doing this from the GUI. So don't worry. But I'll show you the command line also. Here I have also written it, like whenever you are doing this, you can, okay, I made a wrong sequence. Let me correct it. You might get confused because first you have to know about branching. Only then you can know about merging. So when there are no branches, what will you merge? Like you merge two branches together. Okay, so so that both the branches are on the same, they are having the same code. So that's why. So I have changed the sequence now. See, even this is also kept in a version control, so that if someone deletes it or makes a change, I will know what change has been done. So I also kept it, instead of just sending it in a file, it's better to have on a version control, and it's free to store files here. And if other is public repo, but I don't care, like it's good that we are spreading the knowledge. Okay, so coming back, branching is what we are going to learn now. So branching can be done. For example, you have a branch called feature X. For now, we will do a branch called develop, or we will do a branch called stage. So when we create a branch, whatever the name, we switch to that branch using this command, git checkout -b name of the branch. Okay, and when you want to come back to your master branch again, then you can do git checkout master. So git checkout is the command. So git checkout name of the branch, that is the command to do a checkout from one branch to another. And if you want to delete a branch, you can do git branch -d name of the branch. Okay, if you want to do your operations like git add and all, that will be remaining the same. And if you want to push it, you have to write git push and then the name of the branch, origin branch. Okay, so let's try that. Then you will see how these commands are working. Okay, and there are some other commands which can also do the same thing. So I've just added it in the end, rebase. But this we'll discuss later, and we do some advanced commands on git. Not in this session. This is about, like, there is a difference between rebase and merge, so we'll discuss that later. For now, you understand merge and rebase allows you to merge two different branches, like they are same for you now, but later on you understand that rebase does something more than just merging. So we'll get to that later on. For now, let's see how to create a branch in GitHub. So master branch is there, simple, just click on this drop down. It's asking if we want to create a branch. So I want to create a branch called develop, which I'll allow the developers to work from. So it is asking, you want to create the develop branch from master? That means it will copy the code from master and create the develop branch. I say yes. So I just press enter. So now you can see it has refreshed and it says the branch has been created. Now in the drop down, you can see master and develop both. Now we are in the develop branch. If we make any change here, that change would not go to the master branch. For example, if we delete a file, this is a file and I delete it. Okay, I deleted that index copy file. Now in my local, I have that file. I still have that file. Okay, why do I have it? Because number one, I have not pulled, I have not done the git pull. Number two, I am on the master branch. So because I was already working on the master branch, I did not do anything to go to the develop branch. So I am still seeing the file. Okay. Now, how do I go to the develop branch and work? So first thing I can do always is git pull to sync everything from the remote to my laptop. So whenever you start anything, do a git pull. That's a very good practice. Then you do your change. So what it says, new branch has been updated and your current branch is up to date. So master doesn't have any change, but the develop branch, one file has been deleted, so it updated those things. Now if I do this one, I still see the file. Why do you think it is so? Because I am on the master branch. In the develop branch, this file was deleted. Okay, so I am not affected because I was already in the master branch and I was working on the master branch. So it does not affect if you delete or add or do whatever on another branch if you are on the master branch. Like if you are on a different branch, then whatever change happens in the other branch is not affected. Okay, you don't get affected by that. So this helps a lot. So if the development team does some blunders, make mistakes, delete something there, that whatever is running on production doesn't get affected at all. So that is a very good feature of version control. If normally we would have the same thing in a folder and someone deletes it, it's gone. So here, because the branch is different, I am on the master branch. So that's why I still see the file which is actually deleted from the develop branch. Okay. Now, how do I switch to the develop branch? For example, now my team lead, I'm the developer, my lead told me, you go to the develop branch and do this for me. So how do I switch? You don't have to change folder or anything. In version control, you can just switch your branches and do your work and switch back to whichever branch you want. So this command is also very important because it allows you to switch branches. That is the command which I was showing you. Git checkout -b and then the name of the branch. So I am on the master. Where will I want to go? I will want to go to the develop branch. So I do a git checkout develop. So it says you have switched to a new branch develop. Let me clear the screen. Okay, so we can run the same command again just to verify what happens. So he says the develop is already there, so you don't have to do anything. So it gave an error. So that means we have already checked out the develop branch. Now if I do the ls, I can see the contents of the develop branch that already exist, but it still has that file. If I do a git pull, what does it say? That you have to specify the entire path. Okay, so we can try this command just to see if it works or not. Okay, so this has been set up as the remote branch to develop from origin. Then I do a git pull. Okay, and then I do this. Now I don't see the file. So now my system is in sync with the develop branch of this system. So this is how it is. Like this thing is recorded, so you can, I mean, follow all these steps and understand what's going on. So what? Let me just reiterate it. What did I do? First, I did a git checkout -b, then the name of the branch to move to the develop branch. This might seem a bit confusing now, but here I just want to tell you this so that it gets recorded. You can just revisit it later. For now, I would be happy if you at least understand what we did earlier. Master branch, push, add, commit, push, and that's all. Next, this one, how to move between branches. Do this command only once, and if you do it more than once, doesn't matter, it will just show you an error, so no problem. So you move the branch and then do a git pull, but when you do a git pull, it says that you have to set this branch as your original branch now. So what I did, I just copied that command. So Git is very intuitive, like you don't have to remember much. You can just directly write the command. If there is some error, they would give you a suggestion. So the suggestion was git branch, then set the name of the branch here. So I set the name of the branch develop and develop. So it changed everything and moved me to the develop branch. And then I again did a git pull to sync with the remote repo. And now I see whatever content is there in the remote repo, and do the same commands and see what happens. Any errors, just give it back to me. If it is not working for you that way, then you can even do it on the Linux system. Let me just take a few minutes to show you how to do that on the Linux, just in case the Windows doesn't work. So I have that same system which we created last time. So let's start it. So it will boot in a while. So we have a virtual box, and within it we have Ubuntu Linux, and we will be logging in and trying to install Git there. If it is not there already, normally Git is nowadays a default package, so it's already there. If not, we'll install it, and then we'll try the same operations like checking out, cloning the repo, making some change, and committing it. So once we do that, we know it's the same command that you can run from a laptop, from Windows, from Linux, everywhere. So here the username was root or DevOps, I think. For what? No, the username was DevOps and password was DevOps, I suppose. All right, so we have logged in to this system. So here I will do a sudo. This command makes you the administrator. Okay, you can, I mean, this is not mandatory. You can do it, you cannot do it, but it's up to you. I am doing this because we'll check whether we need to install Linux. If you want, you can install as root, or you can use a sudo command before every command to do the installation, because only administrators are allowed installation. Now it is asking for my password, so again I give the same password. So all right, I am logged in as root. When you log in as root, you see the prompt as a hash prompt. Okay, so first thing I'll do is apt get install git. So it checks whether git is there or not, and it says that git is already the newest version, so we have that. So whenever you install Ubuntu, you will normally have it nowadays. If not, you do the same command which I did, and then it asks yes or no. Like after this, if it was to be installed, it will ask you yes or no. You just write a Y for yes, and then press enter, and it installs Git. Okay, so once that is done, next thing we can do is we can write git clone, and then okay, it does not paste to this terminal, so we will have to write that out. github.com, this shopping cart. Okay, https /shopping. This is the git clone URL. So it is cloning the repo into that Linux server. Now if we do a ls, we will see that shopping cart folder is here in the blue. So we go to that folder, cd change directory, go to that folder, do a ls, you see those files are here now. So we have been able to check out that file using git clone. Now say this server wants to make some change on the file, goes to this file, say adds a line, new line added, then I save it, and next what do? I have to do the same operation. Remember, git add, if there is something it will be added, git commit -m, and then you add a comment. Okay, this is good. Now you see something else has come up. Why? This is the error I was talking about. Like I told you, when I am doing it from my Mac, I'm not having to put a username and a password. Okay, why? Because I have already done it multiple times from that terminal, and that username and password is saved. Okay, so when you're doing it from a new system, that will happen in your case. When you will do it from your Windows laptop or from your new Mac, then you will see this for the first time. Okay, so what it is saying, it always gives you, prompts you like what you have to do. So it says you can write git config global user email, and you have to run the git config global username and then press your name, write your name. So let's do that. Git config -global. So here you will write the email that that you use to create that GitHub account. Okay, so I don't think I remember my email, but I remember my username, so let me try with that.
So can I do clone from my Windows OS to Linux virtual machine? Like
Yeah.
that path will it work?
Oh, from your Windows system you create a Git file. Yeah, it will work, but you will have to know your Windows IP address, and
Okay.
then from the Linux you have to do it. So that will be, I mean, a bit confusing. You have to go to your terminal, like command prompt, do ipconfig, then it will show you the IP address of the Windows, and from the virtual box you will have to see whether that is reachable or not.
Okay.
And then, so when we do the Linux networking, we can try those kind of things, like
Okay.
how to communicate between two. So better don't try that right now, because that will complicate things for you and you will get stuck. Right now it will only ask you the username, password, and so on. So
Mm.
let's try this.
Yeah, I have Mac also. I'll do that in Mac, like these
Yeah,
commands.
that will be good, because but try on the Linux also later on. Why? Because in the server, I mean, for now Mac will be good, but in the server, where in case you have to do it sometimes on the server, they will have Linux, so the commands will be the same actually, so no problem. And let me write the usernames. This is the username which we created when we created the Git account, so that has been saved. Now let me run the same commit command again. It might ask for the password. Okay, email address could not be detected, so he will not spare me, so I have to add the email also. So let me try my both the emails. So I think it will be one of them. So this is all self-explanatory. Like until you do the correct thing, it will tell you the same thing over and over again. So we have given the username. Now it's asking, no, you have to give this also. So we are putting the password, I mean username and the email address. Now again we try to commit. So it worked this time. Because this is a public repo, it did not care whether password is given. If the repo was private, it will give another prompt like what is the password, so you then give your password there. Okay, so this part is done. Now we could commit it. Then the last is what? Git push. See, now it is asking your username and the password again. So let me put it there. This is the username I used here and the password. See, I am typing the password, but you could not see it. Like even I cannot see it. In Linux, when you type a password, it is never visible, not even the stars. Like in Windows, you see asterisk, asterisk, those stars come up. So that is even not visible for security. So that person cannot guess how many alphabets and so on. It is more secure. So after the password was given correctly, it did the same thing. Like it pushed the code from master to master. So that is how it works in the Linux. So now say other guy makes a change, you do the git pull and so on. It will be the same thing. And now whatever change we made to that file will come up here again. So we removed we added this line from the Linux. So this new line is added. So that is how this goes back and forth from different like local machines to the remote to local by git pull. So now just let's revisit this thing. I had told you in last session that the git operations might not make sense to you right now, but when you do it at least once, you will understand a little bit more. So next time when you do it again with me, like adding the Jenkins pipelines and all, you will understand something more. So that way your concepts get clarified and you get to understand better. So here, if you look at this now, it makes more sense. These are different repositories on different laptops. Imagine this is GitHub. So this is your laptop, this is my laptop, this is someone else's. So all these people have the same repository, that shopping cart. So whenever he makes a change, pushes it, goes to the other. This guy pulls it, comes to his laptop. This guy pulls it, comes to his laptop. Makes any change, commits it. Okay. Pulls something, his own copy gets updated. So that way the code goes either to the next server or gets pulled from the next server. So as a good practice, everyone pulls first, then makes a change. Why first you pull it? Because you know that your code is in sync with others. Now you can add your own change. But if you add your change and then pull their change, then maybe there is a conflict. So it's better always to before changing any files, pull it. Whatever change will come to your own system, then you make your own changes and push it, then ask the others to do a pull. For example, I have a new project. Okay, so let me create a folder. So let the project name be, say, mobile device. This is the code, something related to mobile devices. So now if we do ls, we can see there is a new project, mobile devices. So we go inside the mobile devices, we write some code, test.java, and inside it some code is there. And I also create some more files. Okay, whatever, like whatever files were created. So this is the code I have. Now how do I create a repo in a local? Like I don't want to create a repo in the GitHub. So to do that, there is a command called git init. It's good that you reminded me this, so I can show you this command also. So if you do a git init, you initialize a git repo. So now your repository can be treated as a Git server. Okay, but whatever change you do now, for example, if you change this test1.java and you add something, tests or whatever, and you do a git add, as per the process, you do a git add, you do a git commit -m test, so everything is working, and you do a git push. This will fail because you don't have a remote. So that brings us to the end of this session. So before we wrap up, let's just go through the git operations once again. So we have a working directory. It's the folder where our code is stored in the local machine, and once we have our code ready to be committed to the remote repository, we first do a git add command, and that allows you to add any new additions in the local repository. And once you run that command, it goes to a staging area. This is a virtual area in a local repository, and from the staging area, when you issue the git commit along with your comments, then the code is ready in the local repo, ready to be pushed into the remote repo. Then if you want to send it to the remote repo, you do a git push command and it goes to the remote repo. Similarly, if you want to update your local repository from the remote, then you issue a git fetch or git pull command, and that syncs it with the remote repo. And there are two other commands that happen. That is the git merge and the git checkout. Git checkout allows you to switch between branches and check out to a new branch, and git merge allows you to merge to more branches. So that is all for the Git and GitHub topic. We did a very good hands-on as well. So you keep learning more, and let's look forward to the next session. Thank you.